Hello, Brant class. Today we are going to be using the long division algorithm to turn quotients that have remainders into quotients that are expressed with decimals. So for example, here we've got 335 divided by 4, and we can get 83 complete groups of 4 in 335, and there are 3 left over. Now, you can write this remainder 3 as a fraction as well, so we've got 3 left over and a complete group has 4, right? So we can also write this as 83 and 3/4. So we can write any quotient as a fraction, 83 and 3/4, but we can write any fraction as a decimal as well. You might know that 3/4 in decimal form is equal to 0.75 or 75 hundredths. I'm going to show you how to do that over here to the right. We're going to rewrite the problem. You're welcome to do it with me or just watch this first one. We'll do a few other examples later. So let me just get through this quickly. We know that 8 4s make 32, which give us one more in the tens place. We bring down the 5, and how many 4s go into 15? Well, 3 of them. That gets us to 12, which means we have 3 4s still left to divide. Okay, here is what's different. Instead of just making this the remainder, if we're going to make a decimal number, then the decimal point would be here. This is the ones place, so the decimal point would be here. And the reason this works is because the decimal places work just like the whole number places. Each place value is 10 times smaller than the place value in front. So the ones place is 10 times smaller than the tens place. The tenths place is 10 times smaller than the ones place, and so on and so forth. So you can keep going into the decimal places, and you follow the same rules as the whole number places. So how do I get a decimal here? Well, this number 335, if you write it as a decimal, it would just be 335 and 0/10, right? Yeah. All these other decimal places would just have zeros in them. So the trick is just keep adding zeros in these decimal places until you have none left to divide. I'll show you how that works. So now that I've got to 3 in the ones place and I can't fit any 4s in 3, then I'll bring down the tenths place. So how many 4s fit into 30 tenths? Well, I can get up to 7. I'm going to put 7 in the tenths place in the quotient. 4 times 7 is 28. So 30 tenths minus 28 tenths is 2 tenths. Okay, so I still have more left to divide, so I'm just going to go over to the hundredths place. Add another 0 here, because remember, adding zeros in the decimal places does not change the value of the original number. Bring down the 0 in the hundredths place. All right, now, how many 4s go into 20? Ha! Here we go. I can get exactly 5 4s in 20. So I get right to 20, and I finally have none left to divide. So now my quotient is 83 and 75 hundredths, which is the same thing as 83 and 3/4. That's our first example. We're going to do 2 more. Okay, our next situation is 257 divided by 8. So it starts off the same way. Nothing changes until you get to the place where you run out of whole number digits. So how many 8s go into 2? I can't do that. So how many 8s go into 25? Well, I can fit 3 8s into 24. So I will take 24 from 25. I have 1 10 left that has not been divided. So let me go over to the next place value, the ones place. So how many 8s go into 17? Well, I can get as close as 16. That's 2 8s makes 16. 17 minus 16 is 1 left. Okay, I have 1 left to divide, and I've run out of whole number places. So I could express this quotient as 32 remainder 1, because I have 1 remaining. Or this could be written as 32 and 1 remaining out of 8, making a total group. So 1/8, 32 and 1/8. Well, let's put this into a decimal. So what I need to do is just add zeros in these decimal places in the dividend. So So if we got a decimal place there, we put a decimal place in the quotient as well. So 257 is the exact same as 257 and 0/10. Same number, doesn't change its value. So now I can add these, bring these zeros down here. And now, how many 8s go into 10? Well, I can fit 1 8 in 10. That gives me 8. 10 minus 8 is 2. So I still have some left. I have 2/10 still left to divide, so I'm going to add another place value. 0 in the hundredths place. Now I have 20 hundredths. How many 8s can go into 20? Well, only 2. 8 times 2 is 16. 20 minus 16 is 4. I have still 4 left to divide in the hundredths place, so I need to go to the thousandths place. Add another 0. There we go. Zoom out so you can see. 40 thousandths. How many 8s go into 40? Ha! We finally made it. We've finally been able to fit 8 perfectly into 40. That's 5 8s go into 40. And we're left with nothing left to divide. So we've gotten to the end. So 32 and 1/8 can be written as 32.125. And I know that's correct because I know 1/8 is the same as 0.125 or 125 thousandths. All right, that's how to do it. There's one more situation you'll run into which gets a little tricky, which I'll show you with the last problem. We're going to divide by 3 now, 170 divided by 3. And maybe you know what's going to happen here, but if not, keep watching, you may be surprised here. So how many 3's will go into 1? Well, we can't get any. How about into 17? I can get 5 3's into 17. That gets me up to 15. And 17 minus 15 is 2. So I have 2 10s still left to divide. I'll go to the next place value, the 1's place, bring down that 0. How many 3's fit into 20? Well, I can get 6 3's. That makes 18. Okay, 20 minus 18 is 2, so I have 2 still left to divide. So this could be 56 remainder 2, or 56 and 2/3. So what would 2/3 be in a decimal? Well, let's find out. I'll add a decimal point here in both my dividend and my quotient, and putting a 0 here does not change the dividend's value. Down here. I got 20 again. Just a second, someone's at the door. Sorry about that. So now, how many 3's go into 20? Well, that looks familiar. We just did 20. Okay, well, 6. All right, 3 times 6 is 18. 20 minus 18 is 2. Well, still have some left over. Add another place value. Bring that down. Got to zoom out. So this is 20. How many 3's go into 20? Well, 6. 18. Okay, 2 left. Got to bring another 0. 20. Wait a minute here. 3 times 6. Do you see what's happening here? We have done 20 minus 18 to give us 2 over and over and over and over again. And really, you could just continue doing this until you get down to 0, and you never would. You'd be doing it for the rest of your life. And I bet you have better plans than that. So what happens in this case, when you've got 2/3, 2/3 is a decimal that will never end. It will be 56.666666666. It will never end. So you can write this in a number of different ways. You could write it as 56.6 with a line over it. Mathematicians write a horizontal line over numbers that are repeating decimals, and that means this 6 will repeat forever. Or more likely, you will just write a certain number of decimal places, like maybe your teacher will say, write it to the second decimal place. And so in that case, you'd write 56.6, and then the second decimal place, but since the place after that is a 6, that means that digit would round up, so you'd write like 56.67. So a couple different ways you can write those, but this is something that you will run into actually quite a bit, is repeating decimals, where you'll just get caught in this same loop over and over and over again. And at some point you just got to say, enough is enough. I got to stop at a certain decimal point. Here we went to the second decimal place, and here we showed a repeating decimal. All right, you've got what you need to know to divide numbers and write the quotients in decimal form.